In the making of a Japanese sword, a rare type of steel known as Tama-hagane is used. According to modern Japanese law, only certified swordsmiths are allowed to create Japanese swords, and only as works of art. Furthermore, these swords must be made from Tama-hagane. For swordsmith, the charcoal used in the forging process is an essential material. The amount needed varies from smith to smith, but it generally takes 10 to 15 bales of charcoal to forge a single sword. In recent years, the cost of charcoal has risen significantly, and for just one sword, the charcoal expenses alone can reach approximately 100,000 yen. But why do swordsmiths still insist on using charcoal? The reason lies in the nature of Tama-hagane itself. This steel contains areas with high and low carbon content, meaning that certain parts need to absorb carbon to become harder, while others require decarbonization to become softer. A charcoal-fired forge creates an environment where carbon naturally flows in and out, allowing the swordsmith to adjust the carbon content of the steel as needed. Tama-hagane contains many impurities, and to produce a single sword, approximately 4 kilograms of this steel is required. However, after the forging process, the final sword weighs only about 1 kilogram. In the Tama-heshi process, the steel is shaped into block-like forms. However, consolidating hard Tama-hagane is no easy task. For this process, boric acid is used. Acting as a flux, boric acid helps bond the steel at lower temperatures. At this stage, Tama-hagane is still very brittle, making it unsuitable for heating at excessively high temperatures. When the boric acid melts, it forms a coating on the wielding surface of the steel. Then, when the steel is hammered, the molten boric acid expels impurities, removing the oxide layer and allowing the steel to bond properly. The next step is called Teko attachment. In this process, a rod-shaped piece of tamahagane, known as the Teko, is fused to a block-shaped base piece. Since the tip of the Teko becomes part of the sword's material, it must also be made from tamahagane. However, as this process is repeated, the Teko becomes shorter and needs to be extended regularly. The straw ash and clay have two key roles. They protect the steel from burning by keeping it from direct contact with air. At the same time, they melt into a glass-like layer, acting as a flux to aid the forging process. A key aspect of Japanese swordsmithing is forge welding, bonding steel at high temperatures without using modern welding techniques. This requires precise control of temperature and hammering techniques, making it a highly skilled craft. Next, we move on to folding forging, one of the most defining processes in Japanese sword making. Unlike steel produced through modern Western manufacturing methods, which is uniform in composition and can be processed by simply extending it, tamahagane contains both hard and soft areas with variations in composition. To correct these inconsistencies, the steel must undergo multiple rounds of folding forging to even out its properties. To enhance the sword's toughness, fragments of other Japanese swords are added during this process. Since tamahagane is produced by low temperature smelting of iron sand and iron ore with charcoal, impurities are not completely removed. As a result, it often contains slag and air bubbles. Western-style swords made from industrial steel can be easily manufactured and provide excellent sharpness. In contrast, a Japanese sword crafted from tamahagane and unrefined steel undergoes folding forging, revealing distinct patterns in the steel and hamon temple line when polished, elevating its value as a work of art. At this stage, the forging of kawagane outer steel is complete. Now, it will be combined with a pre-prepared piece called shingane core steel. By placing the shingane in position and performing another round of folding forging. The core steel is arranged on the upper and lower sections of the blade. This is a technique known as Meikiri construction. As a result, the sword adopts a dual core structure where the shingane is embedded both internally and externally. Next comes Wakashi-nobe, a process in which the steel is heated to a high temperature while being stretched and extended. This technique is now exclusively used in Japanese sword making. Unlike Tamahagane, modern industrial steel cannot withstand such extreme temperatures. It would oxidize from the inside and collapse under the intense heat. Sunobe is a stage where the steel is elongated and shaped before the edge is formed. At this stage, the thickness and width of the blade are gradually tapered. By doing this, the next process, Hizukuri, final shaping, is focused solely on forging the edge, allowing for more precise shaping of the blade. Hizukuri is the process of forging the blade by hammering the steel into its final shape. In Japanese sword making, minimizing the amount of material removed during polishing is crucial. For this reason, the blade is made as thin as possible during this stage, while the surface of the blade appears smooth due to melting during heating. The internal structure does not fully melt, leaving many impurities. This is because Tama-hagare naturally contains a high level of impurities. If too much material is removed during polishing, these impurities may become exposed on the surface, affecting the final appearance and quality. Therefore, shaping the blade as accurately as possible during Hizukuri is essential.
なんでヒューマンエラーヒューマンエラーはもう話にならないです。もう技術が未熟でこうまとめれないとか変なのができるとはもう論外なんですけど、ヒューマンエラーをもう本当にもうなしで材料の由来のもので左右されるっていう世界なんで、今の名人の人もやっぱ10本作ってもそのほとんどは納得いかない作品になる。だからその武道の刀作るからって言ってコールドスチールみたいな鋼材で作ると違法になっちゃうんです。あくまでもこの玉鋼を、何にするにしてもこの玉鋼を鍛えて作りなさい。そしたら最低でも美術品としては美術工芸品として認めて登録書を発行しますよということがある。
Before quenching, a layer of clay is applied to the blade. This process, known as Tsuchioki, prevents the sword from breaking during quenching. At the same time, the quenching process creates the hamon, an important aesthetic feature of the blade. The clay mixture consists of soot, finely crushed whetstone, and shigaraki clay. Though the specific ingredients vary depending on the swordsmith, some swordsmiths even use industrial silica compounds. The vertical lines applied to the blade serve a functional purpose. They prevent cracks during quenching. By applying clay to areas prone to cracking, the construction timing during quenching can be adjusted by fractions of a second, reducing the risk of breakage. This quenching technique is known as dengaku Yaki-ire. The blade is placed on a bed of charcoal, then covered with additional charcoal before heating and quenching. Since Tama-hagane contains many impurities, the polishing process must be done with great care. Due to the nature of the material, whether or not imperfections appear during polishing is partly a matter of luck. While there is some acceptable margin for imperfections, sword making requires significant cost in steel and charcoal. Despite this investment, many swords end up being discarded due to material-related flaws that appear during polishing. I've included a link to Sukemitsu's YouTube channel in the description, so please be sure to check it out.